Time travel is the concept of moving between different points in time, similar to how we move through space. It is a popular idea in science fiction and philosophy, but it also has roots in theoretical physics. There are two main types of time travel often discussed. Traveling to the past. This involves moving backward to earlier moments in time. This concept raises several paradoxes, such as the grandfather paradox, which questions what would happen if you changed something significant in the past, e.g., preventing your grandfather from meeting your grandmother. Traveling to the future. Traveling forward in time is theoretically supported by Einstein's theory of relativity. For example, time dilation. When objects move at speeds close to the speed of light or are in intense gravitational fields, time slows down for them relative to others. Astronauts on a high-speed space journey could age more slowly than people on Earth. Cryonics. Some propose freezing the human body to jump to a future time when it can be revived. While future-oriented time travel has some theoretical basis, traveling to the past is much more speculative and faces significant scientific challenges. Many scientists debate whether it is possible at all. In fiction, time machines, e.g. H.G. Wells' The Time Machine, wormholes, and magical means are often used to enable time travel. There is no verified evidence that people have traveled through time in the way depicted in science fiction, using a time machine or moving back and forth freely through time. However, certain scientific phenomena related to time dilation can be seen as a form of time travel to the future, which has been observed and verified. Time dilation and astronauts. According to Einstein's theory of relativity, time moves slower for people traveling at high speeds or experiencing strong gravitational forces compared to those at rest. For instance, astronauts aboard the International Space Station, ISS, experience time slightly more slowly than people on Earth due to the station's speed and weaker gravity in orbit. This effect is incredibly small, amounting to fractions of a second, but it is measurable. Astronaut Scott Kelly, who spent a year in space, aged about 0.01 seconds less than his identical twin, Mark Kelly, who remained on Earth. Atomic clock experiments. In experiments with highly accurate atomic clocks, scientists have placed one clock on a fast-moving jet and another on the ground. The clock on the jet showed slightly less elapsed time, consistent with relativity. These examples are time travel to the future in the sense that time passes differently for people in different conditions. However, this is not the dramatic, movie-style time travel where someone jumps centuries ahead or goes back to a specific point in history. As for traveling to the past, there is no scientific proof or credible reports of anyone doing so. Stories or claims about past time travel often belong to the realm of fiction, conspiracy theories, or personal anecdotes without evidence. In mythology, traveling to the past is not a common theme compared to the idea of time loops or timeless realms. However, there are a few stories in myths and folklore where time works in unusual ways or seems to move backward. Here are some examples. King Raivata Kakudmi, Hindu mythology. Story: King Kakudmi traveled to the celestial realm of Brahma to seek advice about choosing a suitable husband for his daughter. When he returned to Earth, he discovered that many ages had passed and his kingdom was long gone. Purpose: he sought Brahma's wisdom, but his journey demonstrated the idea of time moving differently in divine realms compared to Earth. While this wasn't traditional time travel, it played with the concept of time relativity. The Seven Sleepers, Islamic and Christian tradition. Story: a group of youths, known as the Ashab al-Kahf in the Quran, sought refuge in a cave to escape persecution. They fell asleep, and when they awoke, centuries had passed. Purpose: their story symbolizes faith, protection by divine intervention, and the mystery of time. This wasn't a conscious decision to travel through time, but a miraculous event. Urashima Taro, Japanese mythology. Story: a fisherman named Urashima Taro saved a turtle and was taken to the dragon palace beneath the sea. He spent what he thought were a few days there, but when he returned to his village, centuries had passed. Purpose: his journey emphasized the fleeting nature of human life and the idea that the passage of time in magical or divine realms differs from the mortal world. Orpheus, Greek mythology. Story: Orpheus traveled to the underworld to retrieve his wife, Eurydice. Although he didn't travel back in time, His journey involved entering a timeless and otherworldly realm. He sought to reverse her death, symbolizing a desire to undo the past. Purpose, love, and redemption drove Orpheus to challenge fate, but his attempt ultimately failed when he looked back at Eurydice before they escaped. The Tír na nÓg, Celtic mythology. Story. In Irish lore, Oisin was taken to the mystical land of Tír na nÓg, where he lived for what felt like a short time. When he returned to Ireland, hundreds of years had passed. Purpose. His journey explored the theme of time distortion and the tragic consequences of being out more. Common themes in myths: divine realms. Many myths involve realms where time flows differently, e.g. heavens, underworlds, or magical lands. Time as a consequence. In most myths, time travel or distortion occurs as a side effect of visiting these places, often highlighting human limitations and the vastness of divine power. Lessons and morals. These stories frequently teach lessons about life, mortality, and the irreversibility of certain events. While these myths do not involve deliberate time machines, they reflect humanity's fascination with bending and escaping the constraints of time. The Clockwork Voyager. Dr. Amelia Carrington was a brilliant physicist who spent her life researching the mysteries of time. One fateful night, after years of tireless effort, her invention, the chronoscepter, was complete. This device, a wrist-worn gadget resembling an old pocket watch, could bend the fabric of time, allowing her to journey into the past or future. Amelia's first journey was to ancient Egypt, a time of pharaohs and pyramids. Disguised as a scribe, she witnessed the construction of the Great Pyramid of Giza. She learned how ancient engineers used ingenious methods to move massive stones, knowledge long lost to modern times. However, her presence aroused suspicion among the workers. Her strange device and foreign language marked her as a potential spy. Amelia barely escaped by using the chronoscepter to leap forward in time. Her next stop was the distant future, a dazzling city of floating buildings and self-sustaining ecosystems. Here, she met Eris, a sentient AI who governed the city. Eris warned her about the dangers of altering the timeline and revealed a startling truth. Amelia's journeys had already caused small disruptions in history. A misstep in Egypt led to a minor collapse during the pyramid's construction, delaying its completion by a decade. Amelia decided to make amends. Returning to ancient Egypt, she disguised herself again and subtly guided workers to correct the structural flaw she had inadvertently caused. The pyramid was completed without further delay, and the timeline remained stable. But Amelia's travels weren't over. She ventured to the medieval era, preventing a war by delivering crucial knowledge to a desperate kingdom. She even visited her own past, offering silent guidance to her younger self during a particularly difficult moment. Through these journeys, Amelia realized the weight of her responsibility as a time traveler. Each visit to the past or future taught her valuable lessons about humanity, resilience, and the interconnectedness of time. Eventually, Amelia returned to her own time, leaving the chronoscepter locked away, vowing to use it sparingly. She became a storyteller, sharing her adventures through novels, ensuring that her knowledge was passed on without risking further disruption of the timeline. The possibility of time travel is a fascinating topic that blends science, philosophy, and imagination. Here's a breakdown of the scientific theories and challenges associated with time travel. Theoretical possibilities for time travel. Einstein's theory of relativity. Special relativity, time dilation, a concept in Einstein's theory, suggests that time can move slower for someone traveling at speeds close to the speed of light. This is a form of time travel into the future, as time passes differently for the traveler compared to someone stationary. General relativity. Einstein's equations suggest that massive objects can warp spacetime, creating paths called closed time-like curves, CTCs, that might theoretically allow backward time travel. Wormholes. Wormholes, or Einstein-Rosen bridges, are hypothetical shortcuts in spacetime that could connect distant points. If one end of the wormhole is accelerated to near-light speed or placed in a strong gravitational field, it could theoretically allow time travel between the two ends. However, no experimental evidence for wormholes exists. Cosmic strings. These are hypothetical, one-dimensional defects in the fabric of spacetime, theorized to have formed in the early universe. Moving cosmic strings could create loops in spacetime that might time machines. Kip Thorne's work. physicist Kip Thorne suggested using wormholes as time machines, provided they remain stable. However, this would require exotic matter with negative energy density to keep the wormhole open, something that has yet to be proven possible. Quantum mechanics. Some interpretations of quantum mechanics, like the many worlds interpretation, imply that traveling to the past could create a parallel universe, avoiding paradoxes. Quantum phenomena like entanglement hint at the complex nature of time, but don't directly support time travel. Challenges and paradoxes. Grandfather paradox. If you travel back in time and prevent your grandparents from meeting, would you cease to exist? This paradox challenges the logic of backward time travel. Causal loops, a self-fulfilling sequence of events where an action in the past influences the future, which in turn causes the past event, creates a confusing loop. Energy requirements. The energy needed to create a wormhole or travel at light speed is beyond our current technological capabilities, potentially requiring more energy than exists in the universe. Current scientific consensus. Travel to the future. Time dilation is well documented through experiments with atomic clocks on fast-moving spacecraft and planes. While practical time travel to the future is theoretically possible, it's limited by our current inability to reach relativistic speeds. Travel to the past. There's no experimental evidence supporting backward time travel, and it may be fundamentally impossible due to physical laws or paradoxes. Philosophical perspective. Even if time travel were possible, the implications would raise profound questions. Would changing the past create a new timeline or affect the current one? Is free will an illusion in a universe where the future might already exist? While time travel remains speculative, it continues to inspire both scientific inquiry and creative storytelling. Who knows? Advancements in physics might someday make what seems like science fiction a reality. The question of whether a time traveler can change past events depends on the rules of time travel and the nature of the universe, which remains speculative. Here are the possibilities based on various scientific theories and philosophical perspectives. Fixed timeline, immutable past. Theory. The past is fixed and cannot be changed, even by a time traveler. Any attempt to alter an event will fail or result in the same outcome. Example. You travel back to warn someone about a disaster, but your actions inadvertently cause the disaster, fulfilling the original timeline. Explanation. This idea aligns with the concept of causal consistency. Events must remain consistent to avoid paradoxes. Paradox avoidance. The Novikov self-consistency principle suggests that any action a time traveler takes is already part of history. Multiverse theory, branching timelines. Theory. Changing the past creates a new parallel timeline or universe, leaving the original timeline intact. Example. If you save someone in the past, you create a new timeline where they survive, but in the original timeline, nothing changes. Explanation. This theory is rooted in the many worlds interpretation of quantum mechanics, which suggests every possible outcome exists in its own universe. Paradox avoidance. No paradox occurs because the original timeline is unaffected. Dynamic timeline, changeable past. Theory. The past can be changed, and any changes will ripple forward, altering the present and future. Example. If you prevent a war in the past, the present reflects a world where the war never occurred. Explanation. This model assumes the timeline is malleable, but it introduces risks like the grandfather paradox. Preventing your ancestors from meeting could erase your existence, creating logical inconsistencies. Unintended consequences. Small changes, the butterfly effect, can lead to massive, unpredictable outcomes in the future. Scientific perspective. Currently, there's no experimental evidence supporting time travel to the past, so the question remains theoretical. Physics suggests several barriers. Causal loops. Any change could lead to a self-contradictory situation. Energy constraints. The energy required to alter spacetime on a scale necessary for time travel is beyond our current capabilities. Philosophical considerations. If the past is changeable, what happens to memories or records of the original events? If multiple timelines exist, would you remain in the new timeline or return to your original one? Popular fiction examples. Fixed timeline, 12 Monkeys, 1995, portrays a loop where all events, even time travel, are predestined. Multiverse Avengers Endgame 2019 shows changes to the past creating alternate realities. Dynamic Timeline, Back to the Future 1985, illustrates how altering the past affects the future. Ultimately, whether you can change the past through time travel depends on which theoretical model of time travel is correct, if time travel is even